This is the procedure for the gas chromatography lab. The first step in your lab book tells you to make up your samples. Thankfully, we have Harold who has already made up your samples, so you can skip over that step. You do want to check your syringe and make sure that the plunger moves freely. You don't want to move it so freely that the plunger comes out of the back of the syringe. The bores are micro volumetric, so it's very hard to get the small syringe back into the small bore without kinking the plunger and rendering the syringe unusable. Make sure you also have a nice straight needle on your syringe. Usually for the first lab, these are in pretty good shape. By the second lab, maybe not so much. Your book also talks about potentially needing to turn on your GC. Ours will already be on, as you can see in the illustration of the GC down in the bottom right-hand corner of the slide. They do contain ovens, which take a while to get up to temperature. So Harold comes in the morning, turns on the ovens, and gets the helium running through our columns. So you don't have to worry about doing any of that as well. I do recommend that you use the same GC for all of your measurements, because sometimes a certain GC will run a little hot or run a little cold. The helium flow may be different within them depending upon how close they are to the tank, and that can affect the retention times if you switch from GC to GC within a particular day. You do want to record the temperatures for your injector, the column, and the detector each time you use it. And you can refer to Travis and Olivia's video that they posted, that they made and I posted, to kind of see where some of that information might be found on RGCs. And also, once we get into the labs and you're actually looking at the instrumentation, it'll be a lot easier to recognize where these temperatures can be read from the instruments. We have 3 samples that you're going to inject separately. So you'll run a sample of ethyl acetate, you'll run one of N-butyl acetate, you'll run isoamyl, and after you ran all 3 of those, you will inject a mixture of those 3. When you're getting ready to do an injection, you always want to make sure that you've rinsed the syringe with hexane, and after you've rinsed well with hexane, you'll rinse with the sample that you're about to inject. Once you're done injecting your sample, you'll rinse again with hexane, and of course you can prep the syringe for the next sample injection at that point. Always be sure once you're done using a GC that you rinse the syringe that you've been using. And this is kind of like your glassware in lab. Always treat it like you don't know where it's been and you want to make sure it's clean. That way you are always cleaning the syringe prior to using it, and you're never making the mistake of using a dirty syringe. Your lab book discusses how to calculate response ratios and dedicates a decent amount of the pre-lab information to these calculations. And this is something that's kind of good to know. RGCs are modern enough that the software is calculating the response ratios and the relative abundances for you. So you don't have to go through and do this process and do all this math. If you do, you kind of end up normalizing all of the data. And so doing the math makes sense, but you don't get any kind of interesting results out of it. You will be running 4 samples in lab, and then you will schedule a time to come back and run an unknown the next day or later in the week at least. Your unknown might have any combination of the 3 compounds that you have analyzed. So it could have all 3 of the compounds, only 2 of them, only 1 of them. You don't really know, but it is up to you to be able to identify your unknown based off of the standards that you will have your GC readouts for. This lab is pretty straightforward. There's only a few potential errors. One of them being not depressing the plunger and hitting the start button at the same time. And we're not working in pairs, but we may need to kind of use the buddy system to make sure that this gets done and that the plunger and the start button are both happening at the same time. Another mistake, cutting off your GC run too soon. so that you don't get the last peak in your mixture or your unknown. Another mistake is not rinsing out your syringe in between the runs and not closing the lid on your vials, which of course is just bad lab habits. You should always close the lids. That way you don't accidentally knock them over or one of your lab members knock them over. Finally, for the waste, these are micro syringes, so honestly, your waste can go onto a chem wipe and it evaporates off. These aren't super volatile chemicals that we're using, but we're not using large enough volumes for collecting them. However, we do have at least a couple of vials in the lab for the rinse ejections. Just to be on the safe side, you can always kind of rinse and eject, and over time, 10 microliters at a time does build up to several milliliters worth of waste. That's all for today's lab. Well, one more thing. We'll have a lab worksheet, so I'll put that up and digitize it in Moodle. So make sure to collect your data, get your printouts. I'll probably have you upload all of the printouts showing what you've done and drawing structures on them, or drawing structures in ChemDraw and putting them up. And make sure to observe your temperatures as well as your retention times for your various samples. Good luck.